Hello, this is a second podcast that illustrates this algorithm that allows to intersect segments of lines in the plane. And for the second podcast, I will just illustrate the algorithm that has been described in the previous podcast by a super simple example. But in this example, we are going to go through all the stages of the algorithm on paper in a tablet. So we have here a very simple case where we essentially have three lines, S1, S2, and S3. And we are going to try to find all the intersection of these three lines using our algorithm. So the algorithm, as described in the previous podcast, requires two data structures. So we are going to initialize these two data structures. The first data structure is the status of the sweep line. So the sweep line is initially above everything, so it's somewhere here. Okay. So the sweep line is somewhere here. Okay. And so the sweep line at this position, okay, the sweep line is here initially. So I will put 0 for initially. The sweep line is there, and tau at 0 is empty, there is no intersection, okay? And the Q is not empty at all. It contains essentially all the events which are upper and lower points of every line, order from top to bottom. So we have E3, which is the most above, E1, E4, E2, okay, E6, and E5. Okay, E4 is above E2. So this is the initial state. Now the sweep line is going to go a little lower. The sweep line is going to go in its second position. What is important to understand, okay, is that between two moves of the sweep line, there is no change in the two data structure. That's the whole philosophy of the algorithm. The only positions where the data structure tau and q are changing is exactly at the events, at the points. When it's between the points, nothing changes. So the ordering of tau is not changing. There is no new event. Okay, let's go further. So further away, when we hit tau 1, we hit E3, we hit E3, what happens is tau now has S1 inside it. And Q, anytime we have an event that has been treated, so now event E3 is treated, it's removed. So it's E1, E4, E2, E6, E5. Okay, now we hit E3. That's what we have to look now, because this is an event which is called an upper point event. We have to look on the left and on the right of the newly inserted segment in the status to look if there is an intersection. But this one doesn't have any neighbor nor on the left, neither on the right. So nothing happens. So now the sweep line goes down, 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 and finally hits E1. It hits here. So this is the third position. It hits E1. Okay, let's call L2. Okay, it hits E1. So what is now the new status? The new status is we are going to add S2, which is the line that is below E1, in the sweep line. So S2 is, with respect to the current position of the sweep line, on the left of S1. So we're going to S2, okay, and S1, like that. Yet, now, at that point, we have to look at the left and on the right of the newly inserted segment, which is seg2. If we have an intersection, on the left, nothing happens. It's the leftist segment. But on the right, we have to look at intersection between S2 and S1. there is indeed a nice intersection between S2 and S1 here. We call it I1, which is the first intersection point. So two things now have to be done in the queue. We have to remove E1, events beyond, and insert I1. I1 is just below, okay, E1. So we are going to have I1, E4, E2, E6, E5. Okay. Now the sweep lines goes from here to the intersection. It goes to the intersection, and we call it L3. It's the third position. So it hits I1. So when it hits I1, I have to swap S1 and S2, because S1 and S2 are the two lines that are creating I1, but I1 is the intersection of. Okay, so TOR 3 is going to be S1, S2, and here we have to look at the left and of the right of this swap if there is no new intersection here. There's nothing on the left of S1, there's nothing on the right of S2, nothing to be done. And in terms of the queue, Q3, we have to remove the event that has been treated. So we have E4, E2, E6, E5. Okay. Then we go down. We hit E4. We hit E4. Okay. We hit E4. E4 is the lower point of S1. Okay. So in terms of, we hit E4. So TOR 4 is going to be, we have to remove S1 from the queue. So S1 has been removed, so we have S2 here. We have now to look, because S1 was there, here, it was there. If there is a new neighbor here, at the left of S2, that have an intersection with S2. Here there is nobody, so nothing has to be done. And so Q4 is equal to E2, E6, E5. Okay, so we go now lower, and we hit E2. Okay, we hit E2. We hit E2. There's a new line, okay, that we have to insert. So TOR 5 S now, and S2 is at the left of S3. So if S2, S3. Okay. Now this is the new one. We have to look at its left and at its right. There is an intersection. Let's look at the intersection between S2 and S3. There is a new intersection point, which is there. Okay, which we call I2. So two things have to be done now in the queue. We have to remove the first one here and insert the new point. The new point is above everybody. So we get I2, E6, E5. And then we go down. We hit now I3. We hit I3. I2, excuse me, we hit I2. When we hit I2, we have to swap the two lines that are creating I2. That I2 is the intersection of. So TOR 6 is simply S3, S2. Okay, and we have to look on the left and on the right of this swapped pair. If there is an intersection, of course there is no intersection here, so we do nothing, and we have simply now to remove the event from the queue. Okay, then we hit E6, we hit E6, we hit E6, so we have to, it's a lower point of S2, so we remove S2, so 7 equals S3, It's alone, okay? Okay, and then we hit E5, so 7 is empty, and Q is empty. And when Q is empty, the algorithm is done, okay? And we're done. So that's pretty much all the stages that are needed to compute the intersection of all the lines. Of course, this is a simple example, but next podcast will present you a code that actually does that in a general fashion. Thank you for your attention.